Storage levels and how to access them. Storage protocols. As we already discussed in our previous video, a hyperconverged infrastructure combines computing, storage, and networking layers. One of the essential parts of the hyperconvergence is how the software-defined storage is presenting or sharing storage devices back to the system. There are various storage protocols, such as iSCSI, Fibre Channel, NFS and SMB. However, the main difference between them is how they operate with the storage on the block level or on the file level. Let's start with block-level storage protocols. iSCSI. Internet Small Computer System Interface, or simply iSCSI, operates on top of the Transport Control Protocol, or TCP. It encapsulates SCSI commands inside the TCP IP packets, and then uses an IP Ethernet network to transport them between the storage system, the iSCSI target, and the server, the iSCSI initiator. As a result, storage connected over the iSCSI protocol is presented to the OS just as an ordinary local LUN. Additionally, by utilizing the TCP IP stack, iSCSI can be used to transmit data over local area networks, or LANs, wide area networks, or WANs, or the Internet. iSCSI has received a wide adoption in the Storage Area Network, or SAN, devices market, and successfully made its way to the hyperconverged infrastructure. With that being said, let's summarize the iSCSI features. Well, first of all, iSCSI works on the common Ethernet network cards, making it really easy to adopt and implement. Moreover, Ethernet networks are typically more budget-friendly than fiber. Secondly, iSCSI works over TCP IP, meaning that there are no actual distance limits between initiator and target, making iSCSI a good fit not only for virtualized environments, but also for backups and disaster recovery. Probably the most controversial thing about iSCSI is the performance. It's commonly viewed to be slower compared to another block-level storage protocol, Fibre Channel. However, several clarifications have to be made here. This perception is based on old iSCSI equals 100 megabyte Ethernet, 1 gigabyte Ethernet usage. However, as not only 10 GBE networks, but 25 GBE, 100 GBE, and even 200 GBE networks appeared, iSCSI can deliver the same level of performance or even higher compared to Fibre Channel. Since iSCSI works over the TCP IP, it's a CPU-intensive protocol. However, with the RDMA implementation on iSCSI in the form of ICER, which stands for iSCSI Extensions for RDMA, iSCSI is capable of directly accessing the initiator or target without involving the default TCP IP stack, thus lowering the CPU load and becoming a good option for high workload environments. Fibre Channel. The next block-level storage protocol on the list is Fibre Channel. Fibre Channel presents block devices similar to iSCSI, since I/O operations are carried out over a network, except it uses fiber optic cables instead of Ethernet cables. In addition to dedicated fiber optic cables, Fibre Channel protocol also requires a dedicated HBA card on the server side to connect the storage array. Usually, it also requires a dedicated FC switch to connect the system. In FC, remote blocks are accessed by encapsulating SCSI commands and data into FC frames. And just as with the iSCSI, the storage presented to the OS over FC is seen just as ordinary local LUN. Now, let's review the main features behind Fibre Channel protocol. FC is a dedicated protocol to transfer data between the storage array and the server. Therefore, unlike with iSCSI, all its bandwidth is dedicated solely for the storage traffic, thus making it a popular choice in a SAN market when high-performing shared storage is needed. On the other hand, this becomes a limitation, with no ability to share FC with other purposes and requiring high capex to implement the storage system based on FC protocol. The benefit behind the FC is that it natively excludes CPU usage from data traffic, delivering high storage performance. Moreover, it operates at 32 Gbps, 64 Gbps, and 128 Gbps rates, becoming a good fit for workload-demanding systems. Since FC has been initially designed as a dedicated storage protocol, it has distance limitations, making it hard to implement for stretched cluster infrastructures, as well as backup and disaster recovery, which means that its purpose mostly is to serve primary storage to the cluster. Now that we're done with iSCSI and Fibre Channel, let's move further to other types of protocols that work on the file level. Network File System Protocol, or simply NFS, pretty much explains its goal: to allow users on client computers to access files on a remote server over a network. Basically, the server implements an NFS daemon process to make data available to clients. Not to share all the content, the server administrator decides what to make available and ensures it can recognize validated clients. From the client side, the machine requests access to the exported data, typically by issuing a mount command. If successful, the client machine can then view and interact with the mounted file system. Putting it simply, NFS is a protocol that allows sharing files with multiple users over a network so that users could access them. NFS is typically used in Unix-based systems, although it's also available on Microsoft Windows. It has to be noted that NFS can work over both TCP and UDP protocols. Correspondingly, when using UDP, NFS establishes a stateless network connection, meaning it doesn't acknowledge that the packets being sent have been received between the client and server, which can translate into better performance. However, because UDP is stateless, if the server goes down unexpectedly, UDP clients continue to saturate the network with requests for the server. For this reason, TCP is the preferred protocol when connecting to an NFS server. Let's look at the main features. Quite simply, NFS provides a central file sharing management and allows users to access the required files remotely. Therefore, NFS has become a popular protocol for implementation in NAS, or Network Attached Storage Devices. Also, it's extremely simple to set up and access. Another file-level protocol is SMB. Just like NFS, it's used to provide access to files stored on a server to multiple users over the network. So what's the difference? Well, first of all, SMB is a file-sharing protocol designed for Microsoft Windows operating systems. Secondly, it's how you authenticate with SMB. With NFS, the server administrator determined the access policies to the files, while in SMB, there is also a user-level authentication requiring a username or password to allow access to the server. And finally, SMB communicates only over the TCP protocol. The unique feature of SMB is RDMA support, which is called SMB Direct. Although SMB can be emulated in Unix-based systems, it's mostly used inside Windows-based infrastructures, and therefore, just like NFS, SMB is another protocol you'll commonly see in the NAS devices. Now, storage technologies do not stay in the same place and keep on developing extremely quickly, with NVMe drives and object storage becoming a common choice for more and more infrastructures. At the same time, the existing storage protocols are also developing to meet the modern storage requirements. Let's first try to understand what object storage is. Unlike file or block storage, where data is kept as files in folders or as blocks on servers, object storage has a flat structure where files are broken into pieces and spread out among hardware. In object storage, the data is broken into discrete units called objects and is kept in a single repository. Each object contains a unique identifier and the metadata that describes the data. To retrieve the data, the storage operating system uses the metadata and identifiers, which distributes the load better and lets administrators apply policies that perform more robust searches. Now, how do we communicate with object storage? Quite simply, object storage systems speak RESTful HTTP protocols, the same language as the Internet. Therefore, no wonder most of us associate object storage with cloud providers such as Amazon Web Services or Microsoft Azure. Additionally, some object storage systems support two other important HTTP-based protocols: Amazon Web Services Simple Storage Service APIs, known as S3, which is a de facto standard. CDMI, the Cloud Data Management Interface, is an industry standard API specified and promoted by the Storage Networking Industry Association, or SNIA, for accessing cloud storage. But what about NVMe drives? Well, all you want from NVMe is performance. The common storage protocols such as iSCSI or FC can serve this purpose, but the most challenging task is latency. With high latency, you lose the benefit of having NVMe in the first place. Any common block or file protocols will generate additional latency due to internal overhead. To overcome this challenge, the NVMe over Fabrics, or NVMe-oF industry standard, was launched in 2016. To put it simply, NVMe-oF is a network protocol, like iSCSI or FC, used to communicate between a host and a storage system over a network, aka fabric. Industry development efforts are currently focused on two types of fabric transports for NVMe. NVMe over Fabrics using RDMA, ROCE, iWarp, and InfiniBand, and NVMe over Fabrics using Fibre Channel, FC NVMe. What matters is that NVMe-oF has very low latency, in practice adding just a few microseconds to cross the network. This makes the difference between local storage and remote storage miserable. As with any other storage protocol, it can be used to access a simple storage box filled with NVMe drives, as well as a feature-rich block storage system like SAN. Thank you for watching. If you have any questions, feel free to leave them in the comments section below. Tune in next time to learn about different storage types in detail.